India has the unique distinction of being the only country in the world producing all the 4 varieties of natural silks and cocoon was mulberry, tussar, muga and eri on commercial scale. Mulberry silk is taken from mulberry cocoon. Since mulberry silkworm bombyx mori is a monophagous insect and eats only mulberry as a sole food plant, hence the name mulberry silk. The remaining 3 types, tussar, muga and eri, are called non-mulberry silks, belong to the order Saturnidae. The share of the non-mulberry silk production is 9.5% of the total silk production. The non-mulberry production is an asset to the nation as it serves as a means for socio-economic needs of the millions of tribal inhabitations in rural India. Until now, while silk reeling has remained as an exclusive tribal craft and practices employed are quite traditional and primitive. The non-mulberry silks are the tussar silkworm is called as Anthrea mylitta, eri silkworm Phylloxera racinae, muga silkworm Anthrea asama. The mulberry silk caterpillar belong to the order of Lepidoptera winged insects genus Bombyx mori, which can be cultivated indoors, produces over 90% of the world output of raw silk used commercially. The mulberry silkworm is a poikilodermal and holometabolous insect. It completes its life cycle in about 50 to 55 days, involving 4 metamorphosizing stages, namely egg, larva, pupa and moth. The larval stage is the only stage when the silkworm takes food, that is the mulberry leaves. The duration of the larval stage is about 25 to 28 days. During the larval period, the silkworm casts away its sin 4 times, as this process is called ecdysis. Interestingly, the larvae from the time of hatching till it becomes a fully grown larvae 25 to 26 days increases in weight by about 10,000 times, in volume by about 7,000 times, as in a body surface by about 400 times. Each larvae during this period eats 20 to 25 grams of mulberry leaves and spins a cocoon weighing 1.5 to 2 grams. There are 2 types of mulberry cocoons generally reared in India. They are multivoltine cocoons and bivoltine cocoons. Multivoltine cocoons are yellow, golden yellow in color. They are flimsy, flossy with shorter filament length, and shell percentage is lower in the order of 13 to 17%, and the raw silk percentage in the range of 7 to 10%, whereas bivoltine cocoons are compact with longer filament length and shell percentage is higher in the order of 18 to 23%, and the raw silk percentage is in the range of 11 to 15%. Since nature has already spun a long continuous silk filament, that is the fiber, there is no further spinning to prepare the yarn as in the case of other natural fibers, except that the individual long filaments are combined together after unwinding them from the cocoons and winding the resultant yarn onto a convenient device. This process is called silk reeling. Silk reeling is simply the unwinding of filaments from a group of cocoons in hot water bath onto a reel. Now, let us look into the mulberry cocoon processing. Preparation of mulberry cocoons for reeling is by boiling and brushing. The objective of cocoon cooking is to soften the sericin so that the cocoon shell is loosened, enabling the filament to be unwound smoothly. The cooked cocoons are brushed to remove the flaws in order to get the true end of the filament. In India, there are three distinct reeling devices in mulberry sector, namely the charaka. This is a crude system of reeling comprising of about 35,000 units whose production contribution is about 50% of the total silk production. Secondly, the cottage basin system improved over charaka comprising of about 20,000 units whose production contribution is about 40% of the total silk production. And lastly, the multi-end basin system comprising of about 4,000 installed basins. Of these, about 3,000 are active and their production contribution is about 5% of the total silk production. However, systematic research studies on the cocoon processing such as stifling of cocoons and cooking have been made at Central Silk Technological Research Institute, Bangalore on multi-end as well as automatic reeling machines with both improved quality multi-voltane and bivoltane cocoons in order to work out the feasibility of introducing modern automatic silk reeling under Indian conditions. The double cocoons are used for the production of dupion silk. Dupion silk is reeled on the charaka and the cottage basin at high temperature, maintaining 1 or 2 ends without croissure. The famous handspun tussa, so popular in America and Europe, comes from the obscure remote forest areas of 5 Indian states: Bihar, Madhya Pradesh, Orissa, Andhra Pradesh and Uttar Pradesh. The wild tussa silk cocoon hanging on a peduncle from the twig is mistaken as a fruit. The cocoons are seen in various colors of brown, grey, yellow and pink. The tussar cocoon, unlike the other cocoons, has 3 layers of continuous filaments plus the inner finer strands of the chrysalids. The first 2 layers are unique in that the outer layer is solidly cemented onto a hard shell. It measures about 5 into 3 centimeters. The continuous inner filament is lustrous and varies in color from brown to various shades of tan to silver grey. It is hard to reel because the filaments do not readily form a thread. The tussar cocoon, at the anterior end, there is a well formed dark brown peduncle with a ring at the distal end. The cocoons are generally yellow or grey. The females spin larger cocoons than the males. The size of the male cocoon is 5.1 into 2.9 centimeters. Its peduncle length is 4 centimeters. Its volume is around 28.6 cubic centimeters. The weight of the female cocoon is 11.1 grams and its shell weight is 1.4 grams with a shell ratio of 14%. During the light hours, spinning of the cocoon is initiated by the formation of the ring and peduncle and then start spinning the cocoon. During spinning, which is most regular, the head movements of the larvae trace a horizontal figure 8. In 24 hours, the larvae is completely enveloped by the cocoon, but spinning continues for about 2 to 3 days, during which the cocoon shell is further thickened. The larvae should not be disturbed during the spinning. After spinning, it places its head towards the peduncle end. Before pupation, which takes 4 to 6 days. The larvae very slowly discharges a small quantity of light milky yellowish substance for about 2 to 3 hours. Upon drying, the discharge makes the cocoon yellow or grey. Now, the tassar cocoon processing. Tassar cocoon is very hard and compact, unlike the mulberry cocoon. It cannot satisfactorily be softened by boiling in plain water. The pore solubility of the sericin in water and alkaline acidic solution due to the presence of tannin substances make the cooking and degumming of tassar cocoons difficult. Wet basin reeling of tassar is not advantageous. Therefore, the tassar cocoons are wrapped in silk waste, especially at the peduncle end, to prevent the shell from bursting, and are treated in a boiling alkaline media for about 4 to 5 hours. This technique involves much labor. This process is also called as enzymatic cocoon cooking. Enzymatic decomposition of sericin at low temperatures renders it soft enough for reeling. Solutions of cocoonase, pepine, trypsin, pepsin and biopril 50 have been tried. The last one have been found to be the most efficient because it is not only provides uniform softening but also reduces the cooking steaming period. Different application of this new cooking technique for Anthraea mylitta and prole. For Anthraea mylitta, the cocoons are first boiled in plain water for 1 to 1.5 minutes, then steamed for 15 lb per square inch of steam for 40 to 60 minutes. Then they are left in the chamber and the pressure is gradually released. The cocoons are then loosely wrapped in a porous cloth and soaked in 0.1 to 0.2% biopril 50 proteolytic enzyme solution for 20 to 22 hours, initially at 40 to 50 degrees centigrade and later at room temperature. After being spread out on a bed, the cocoons are semi-dried and then deflossed for dry basin reeling. This method gives about 65% raw silk percentage with daba and bogai. If cocoons are pre-boiled with soap and soda solution, concentration of biopril 50 may be lower. Despite the upsurge of mill-made cloth, the old and respectable Assamese even today proudly wear their native outwear and turbans made from Muga silk. In Assam, women love to wear silk wraps, mekhelas embroidered with arresting designs. Assam produces nearly 60 to 70 metric tons of Muga raw silk every year. The Muga worm Anthraea assama is semi-domesticated and breeds several times a year. The Brahmaputra valley in Assam is also the home of the rare silkworm moth, the Anthraea assama, producing golden yellow silk. The tribals inhabiting the regions have carried on the production of Muga silk as a tradition. Assam, Ahom kings favored Muga silk for court and ceremonial dresses. There are few hundreds of families engaged in rearing Muga worms, reeling their cocoons and weaving the rich fabrics. Because of its high tensile strength, Muga silk thread is widely used for embroidery and in making fishing lines. The Muga worm is fed on the leaves of food plants, particularly on som, Bacillus odoratisama and Solum Teranthera monopetalia. A som and sol tree is considered fit for rearing for silkworms only after it is 4 years old. The Muga silkworm gives 5 breeds a year corresponding to the different seasons. They are Katia, that's the autumn crop, Jaruva, winter crop, Jetuva, summer crop, and Ehia, early monsoon crop, and Bhadia, late monsoon crop. The bulk of the cocoons comes from the autumn crop, which is considered more prolific than other crops. The Muga cocoon is single shell, light brown, oblong, closed, reelable and slightly flossy with a weak peduncle. It measures about 5.2 to 2.4 centimeters in size and weighs about 6.3 grams with a soft shell of 0.5 gram and a 9.5 shell ratio. The cocoon is golden brown or glossy white. Muga cocoon processing. The average production of raw silk is 8 ounces from 100 Muga cocoons. The reeling contrivance is known as bir. The Muga cocoons are first cooked in an alkaline solution for nearly an hour until the filament is easy to put out. The rarer themselves do much of the Muga reeling, but there is a class of people proficient in Muga reeling. Muga silkworm reeling and weaving of the Muga silk not only represent the tradition, culture and sentiments of the Assamese, but also plays a vital role in the economy of rural Assamese. Besides, because of its natural golden color, durability and texture, Muga silk has become a fascination even outside the northeastern India, indicating a tremendous market potential for this unique silk. Muga reeling cocoons are usually sold in thousands. In order to give a fair price to the Muga cocoons, they are graded as A, B and C grade cocoons. The Muga cocoons are compact and leathery in structure, and continuous silk filament varies from 350 to 450 meters with 4 to 5 breaks. Further, in Muga cocoon, since finding out the end of the continuous filament is very laborious as well as time consuming, the reelability itself is very low. Only 40 to 45% of the silk filament is reeled and the rest of the silk content is rejected as a waste. Muga cocoons are boiled in an alkaline solution for about 15 to 30 minutes depending on the strength of the alkaline solution, compactness and freshness of the cocoons. Depending on the quantity of the soda, the boiling period is adjusted. Either they use 3 grams soda in 1 liter water and they boil the cocoons for 10 to 15 minutes, or they use 1 gram soda in 1 liter water and boil the cocoons for 30 minutes. Also, the cooking period is adjusted as required for fresh and old cocoons. The cooking period is reduced if the cocoons are fresh and the cooking period is prolonged if the cocoons are from the old stock. But all these are based on visual judgment and the experience of the reeler. Eri cocoons are domesticated in Assam since time immemorial. Eri silkworm is biologically named as Phylloxera racinae. It belongs to the family Saturnidae under order Lepidoptera, a class Insecta. It is a multivoltine breed having 5 to 6 life cycles in an year. The commonly occurring wild Eri silkworm is Phylloxera racinae, which is either bi or trivoltine in nature. The life cycle of Eri silkworm has 4 stages: egg, larva, pupa, encased in cocoon and adult moth. A complete life cycle lasts for about 44 days in summer and 85 days in winter. The cocoons can easily be distinguished from those of Anthrea as they are elongated, soft, woolly, pedunculous, open mouthed and unreliable. They measure about 4 into 2.5 centimeters, weighing about 3 grams and exhibit color polymorphism, being brick red and creamy white. The shell weight and shell ratio are about 0.4 grams and 13% respectively. Assam airy silk carries a reputation for softness, durability and is an ideal fabric for cold countries. The fabric possesses a natural cream color and a rare natural hand woven look. Both the twisting and spinning processes are primitive, but the cloth retains the natural beauty of the fibers and makes the ideal material for fashion designers. Assam, Jagirod and Bihar Bhagalpur spun silk mills set up by the government utilize most of the cocoons and other silk waste of eri cocoons. As the eri cocoons are open mouthed and not composed of continuous filaments, they are not reliable. They form a good raw material for spinning. For spinning eri cocoons, clean and empty eri cocoons free from dry chrysalis skin and large larval skin are used. Such clean cocoons contain 100% silk and fetch high price unclean non-fibrous material. Pupa and molted skins get entangled with the silk fibers spun and more so with the movement of the machinery used for spinning. Hence, cleaning of the cocoons is a prerequisite to spinning. Some animistic rearers in Assam eat the pupae of cocoons and leave them clean. Cocoons can also be cleaned by corridor cocoon reverser, a simple machine by which the cocoons are turned inside out and all waste materials eliminated. This machine is rarely used these days. Cocoons are first boiled in a solution of soda or potash. Plantain leaves or leaf ashes, wood ashes, ashes from wheat stalks, paddy straw, black pulse plants and pieces of green papaya can also be used for dissolving certain portion of adhering gum round the filament. Unless a part of the gum is removed from the cocoon filament, it cannot be spun on cheraka or takli. Certain solvents color the cocoon and hence the yarn is also colored. Soda ordinarily gives a brown color to the yarn. Pulses and plant ashes impart a creamy luster and papaya pieces provide a whitish luster. The quantity of soda to be used depends on the quality of the water and the duration of boiling. A minimum of 10% of soda by weight of the cocoons may be tried and increased or decreased after observing the behavior of the material. Cocoons are tied in a piece of cloth, loosely weighed with stones and dipped into vessels containing the solution. When sufficiently boiled, the bag is taken out and washed in cold water several times to remove the solvent. The cocoons are squeezed until a large part of the water is wrung out. They are then spread and dried. The cocoons thus prepared can be spun in wet condition with takli and semi-dry condition with hand charaka, the eri spinning wheel. So far we have seen the different types of cocoons and the different types of cocoons that are cultivated in India, and India is being the very unique country producing all the 4 types, the mulberry cocoon and the 3 non-mulberry cocoons. We have seen the various varieties, the various cocoon processing technologies and cooking technologies involved in the processing of these cocoons.